All right, this is the notes for section 7.2, slide number 18. All right, so this example says evaluate the definite integral from -2 to 2 of the square root of 4 minus x squared with respect to x graphically. All right, so that means I need to know what the square root of 4 minus x squared looks like graphically. All right, so let's let y equal the square root of 4 minus x squared. All right, so square root of 4 minus x squared. Now, let's square both sides. So I get y squared equals 4 minus x squared. All right. And let's bring the x squared to the other side. So x squared plus y squared equals 4. All right, so if this is true, well, what does that mean? Well, that means this is a circle centered at 0, 0, and a radius of 2. Remember, this is in the form like x minus h squared plus y minus k squared equals r squared, right? So hk is the center and r is the radius, right? So now remember, when we solve for y, we actually get just the positive square root of 4 minus x squared, not the negative, right? Because there's no negative sign in front. So it's actually just the top half of that circle. So it's the top half of a circle centered at 0, 0 with a radius of 2, right? So this thing goes from -2 to +2, right? And we are trying to find the area under this curve, right? So really, it's just the area of a half circle of radius 2. So remember, that would be half of a circle, right? So half of pi times the radius squared, right? And the radius is 2, so 2 squared is 4. And so half of 4 is 2, so the area, the answer to this integral would be 2 pi, okay? All right. Um, Next example. Given that the integral from 0 to 3 of h of x dx is 9, and the integral from 0 to 3 of g of x is 9 halves, what would the integral from 0 to 3 of 4h of x minus 2g of x plus 1 dx be? Well, all right, so first thing we want to do is we want to recognize these two things are, or sorry, these three things are added or subtracted, so we're just going to integrate them separately, okay? Now, also, if I have 4h of x, that's like 4 times the integral of h of x. So integral from 0 to 3 of h of x. All right. And then dx, right? Remember, we need to bring that in. Then minus 2 times the integral from 0 to 3 of g of x. And then lastly, we have plus 1. Right now, remember, this would be like plus the integral from 0 to 3 of 1 dx. Now, a lot of people make a mistake with that. They kind of forget that the integral also applies to that 1. All right, so the first one, we are given the integral from 0 to 3 of h of x up here is 9. So this is just 4 times 9 minus 2 times the integral from 0 to 3 of g of x. Well, integral from 0 to 3 of g is 9 halves. So 2 times 9 halves. And then plus. Okay, now common mistake is they just say, oh, well, plus 1. So this is just plus 1. No, this is the integral from 0 to 3 of 1. Now remember, this would be like saying y equals 1, right? So what is the graph of y equals 1? Well, y equals 1 is a horizontal line, right? And so we're looking for the area under this curve from 0 to 3, right? So what would that be? Well, that would be this rectangle, right? That is 3 units wide and 1 unit tall. So an area of 3, and so plus 3. All right, so 4 times 9, 36. And the 2's here would reduce. 36 minus 9, right, gives us 27 plus 3. So 30 is our answer there. All right. And then lastly, all right, express the integral from a to b of f of x minus the integral from c to b of f of x dx as one integral. All right. So I'm going to go ahead and draw a little picture just so we can kind of understand this. All right. So here is some curve, let's say. All right. And let's say that I have a here and b here. Right, so the first integral represents the area from A to B, right? So that would just be this area. Okay, now, what would the integral from C to B represent? Well, let's say that we have some other value. let me, all right, let's choose a different color. Let's say C is right here. All right, so now C to B would represent the area just from C to B, right? And so if I take the area from A to B and I subtract the area from C to B, what am I left with? Well, I'm left with the area from A to C. And so our answer is the integral from A to C of f of x dx. Right now, it does not matter what order the variables are in, right? It actually, if we go, if we put B in between A and C, this is still true. It doesn't really matter, no matter where things are, okay? And so the integral from A to C. All right. Now, how can we think about this? Well, we can think about this by saying, okay, well, if I want to take these values, right, and flip them, all right, then that means I can put a negative in front, which means that this would become a plus. And so what does that mean? That means I would have the integral from a to b of f of x dx plus, right, because we changed the sign, the integral from b to c, sorry about this, of f of x dx. And so that means that when we have the same limits on the diagonal, we can join together and then we get the integral from a to c. And so this would be our answer. All right, so that is slide number 18.